Okay, so at the top of your page, let's go ahead and write the limit as h goes to 0 of f of x plus h minus f of x over h. So that's the formula that we're using. I know that you guys don't like how small I make the space on here, so if you want to work on a separate sheet of paper, you're welcome to do that. Toby, I'm about to rip that up and spit on it. Oh, marvelous. The Sudoku thing underneath it needs to go bye-bye. But like all the way bye-bye? Yeah, she meant that, but it's okay. If you take it out, I will spit on it, rip it up, throw it at your eyeball. Yes. Yes. Because remember in the definition, h was talking about a distance. It was like the distance of how far apart the points were. And we want that to get closer and closer to 0 because then we're basically saying 1 point by itself. So that's why it always goes to 0. Okay, so what do I write for number 1? So I've got the limit as h goes to 0 of and then make sure when you're doing this part where you're subtracting off the f of x, you have that whole thing should be in parentheses because you have to distribute that negative. So make sure you get that part right. Okay, now what I like to do, because having an x plus h squared is kind of common for these problems, so what I like to do is just do it off to the side and then I can just always use it when it happens. So x squared plus xh plus another xh plus h squared. Yeah, that's fine. So that means that now I have the limit as h goes to 0 of 2 times that stuff minus, I'll go ahead and distribute, minus 7x minus 7h plus 1 minus 2x squared plus 7x minus 1. And then I can go ahead and distribute that too. Isn't it wonderful how ridiculous these problems get? And then everything just cleans up. I love that. All right, so what do you guys see? Gone. And the 1 and the 2x squared. So I'll pull the h out. That gives me 4x plus h minus 7. So the limit as h goes to 0 of plus 2h minus 7 equals.
Wait a second. Why would there be plus 2h?
Because there's 2h there.
Yeah, but isn't there still a minus 7?
Oh, yeah, that was the mistake. Okay.
Oh, we factored it out. Okay.
I factored an h out, yeah.
I just forgot it was 2x, so I ended up with 2xh instead of 4xh.
The 2 on the front. Yeah. All right, so we plug in 0 and we get okay, so this means that f prime of x is 4x minus 7, so that's the derivative written as an equation. And then to find the derivative evaluated at 3, we will plug 3 in. 4 times 3, take away 7. Okay. Wasn't that fun? Yeah. Marvelous. Enjoyed that. Yeah. So what I've done here, which you may or may not love, also look at this. My document camera has a little remote. So if I'm like, oh, I just really need to zoom out right now. Hold on, I have to look at the thing. Ooh, that's silly. Oh man, like, cause yeah, it's meant for like, it's different because some people use these for presentations. So if I was like across the room, that'd be fine. But I'm a teacher, so I'm gonna be right right up here writing stuff. But if they had something they didn't need, they just needed to zoom in. I don't know. But business people use these too, not just teachers. So anyway, I think that it's wonderful that I have a remote so that if I don't feel like reaching across, I can just zoom in, zoom out. So what's about to happen on number 2 is you are going to have a limit and it's going to be a complex fraction. What's going to happen on number 3 is you're going to have a limit with a radical and you're going to have to do the conjugate. Number 4, you're also going to have a complex fraction. So you're going to kind of run into some of those methods that we used from Unit 1. We're still going to be using them now because those methods are still valid. Does that make sense? By the common denominator. All right, so go ahead and work on that. The answer key is on the board if you need to check it. Yes.